This is AP Calculus AB, year 2010, first response question number 5. Here we are given a graph. It says the function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 equals 5. The graph of y equals g prime of x. The derivative of g consists of a semicircle and 3 length segments, as shown in the figure above. Find g of 3 and g of -2. So for this problem, we have to keep in mind that something is already given, which is g of 0 equals 5. So here we're given the function of a derivative, and it's asking for g. So first let's solve for g of 3. So we have to, like I said, we have to keep in mind that it's given that g of 0 equals 5. So g of 0 plus, since it's asking for regular g, we're given the derivative, so we have to integrate in order to undo that derivative and come up with the original equation. Now here, so basically we have to figure out the distance between here. So here we have half a circle, so we know that a full circle would be 4 pi, so it's only one. We're only accommodating for 1/4 of the circle, so that'd be pi. And here, for this triangle, it'd be 3/2. So from there, just simply plug in your values. So g of 0, g as 0 is 5 plus pi plus 3/2. And that's g of 3. Same thing goes for g of -2, except we're going to be going backwards. So once again, accommodate for the g of 0. Except this time it's going to be from 0 to -2, because that's what it's asking for. So this is going to be -5. Once again, we have to integrate that derivative in order to undo it and come up with the original equation. Or I mean the original value of g of x. So once again, g of 0 is 5. And then the distance, or the area, you would say, from 0 to -2 of g prime is -5. So there you go. Now, for part B, it says find the x coordinates of each point of inflection of the graph of y equals g of x on the interval -7 to 5. Explain your reasoning. Now here so we know that points of inflection have to do with second derivative. We also know that the points of inflection of g of x are relative extrema of g prime of x. So just by knowing that, you can figure out your points of inflection. So here, clearly we can see a point of inflection at x equals 0, x equals 2, and x equals 3. So there you go. G of x has, I'm just going to write POI to shorten it. Inflection at x equals 0, x at x equals 2, and x equals 3. Got it. So for part C, it states the function h is defined by h of x equals g of x minus 1/2 x squared. Find the x coordinate of each critical point of h, where on the interval -7 to 5, and classify each critical point as a location of a relative maximum, relative minimum, relative maximum, or neither a minimum nor a maximum. Explain your reasoning. So what we're given is h of x equals g of x. We're given this function on the problem. Now, for critical, well, first of all, we know that for either relative minimum or relative maximum, we need to find our critical points. So in order to figure out our critical points, we need h prime of x, which would be g prime of x minus x. Now, in order to find our critical values, we know that h prime of x would have to equal to 0. So in order to h prime of x equal to 0, g prime of x has to be equal to x. reasoning. So from there, we can look at our, if you know your circles, clearly one of your x's is going to be radical 2. And then we can also, might as well draw the line out because we're going to need that for later. So yeah, if you know your circles, clearly you know that one of your x's is going to be radical 2. And your other x is going to be 3. So from there, now all we got, those are our critical points. Now from there, all we gotta do is just figure out if it's a relative minimum or relative maximum or neither. Now, if we go ahead and look at radical 2, we know that any value that is greater than g of x is going to be positive. So, for example, right here, it's going to be greater, that would be positive. Now, with that reasoning, any value that is lower would be negative. So that is a signing change from positive to negative. So that states that it would be a relative max, h of x. So clearly there would be a relative max at x equals radical 2. And earlier I stated greater than g of x, but I meant h of x. So h of x as a relative max at x equals 2. Because like I said, h of x, h prime, which we know is g prime of x minus x, which is represented here, there's a relative max at x equals radical 2 because h prime of x changes from positive to negative. So there's a sign change, that is the main idea. Now for x equals 3, right here, we could see that the slope will be negative, and then since it's a point, not a point, but since it's a triangle, it would be 0, and then it'll go back to being negative, so there's no sign change. So these would be both negative, there's no sign change, it's neither, it would be neither. So then x equals 3 is neither a relative none or a max, because there is no sign change.